So at this point, we've learned a lot about oil. We've talked about how certain things break down, organisms, particularly those that are high in fats or fatty acids, as opposed to those high in cellulose. Right? So we talked about zooplankton and some types of algae. As those break down, those fats convert. Right? We talked about that. They turn to kerogen as that gets buried really, really deep. That kerogen, those really, really, really complex molecules, as they're exposed to heat and pressure, they break down into these organic alkanes, octane, methane, and then that becomes buoyant and rises to the surface, right? So it's a little bit of a review from the last video. Also, we talked about how plants that are really high in cellulose, woody plants, so ferns and trees and shrubs and all kinds of fun things like that. There's too much oxygen, and in that case, the oxygen bonds with the hydrogen, oxidizes the hydrogen, and it won't form these long chain hydrocarbons. Generally, things that are high in cellulose will produce coal, which, surprise, we're going to talk about in a couple of weeks. And the other thing that's worth pointing out is that this lecture on oil is going to last about 2 weeks. We may start getting into some oil stuff next week, but we have more to talk about, and this will be the last video for this week. Okay, so we've built oil, right? At least chemically and geologically, and we've had it rise up through the porous earth, right? Through porous rocks, particularly sandstones, things that have porous space. We also talked about some types of rocks don't have pore space, and those form oil traps, right? So as oil is rising, it gets stuck under these traps. So you can see here is an image. We've already seen this image in the last slide, but it can hopefully remind you about these oil traps. So if that doesn't happen, the oil will actually rise all the way up to the surface. And that is going to allow us to transition into talking about oil recovery, right? Because that's the name of the game, right? We want the oil, we need to recover it. And frankly, we've been doing that for a really long time, although maybe not in ways that you think. Oil rises to the surface, and when it does that, it forms what we call an oil seep. And actually, we as humans have been taking advantage of these things for a long time. Probably one of the most famous oil seeps, particularly in the US, is actually the La Brea tar pits. Right? Tar is oil. It's seeping up from underground. When we think about the history of oil use, we actually have to kind of couple that with the history of humans, right? And so there's a lot of oil seeps that people have been taking advantage of essentially in the Middle East and China, right? And if you think all the way back to our population discussion, people have been around there for a long time. Actually, when we look at Babylon, right, so the famous town of Babylon, there was actually tar incorporated into the walls as a construction material, right? So we've been using it for a really long time. In old portions of Baghdad, which is in the Fertile Crescent, kind of in the cradle of modern civilization, they actually would use tar that they would recover from these oil seeps to asphalt or tar the streets, right? Way back in antiquity. So we've been using it for a long time. The Chinese famously were really the first to use it as a fuel rather than a construction material. So around 400 AD, the Chinese began pulling oil out and realizing that it burns, you can use it as a fuel, and they also were the first to drill to it in like very, very rudimentary ways. They would use bamboo pipes that they would drive down into these incredibly shallow oil reserves, and from those bamboo pipes, they would extract this oil to use for fuel. But it was really expensive. They didn't have much oil, so it really was kind of run off to the wealthiest, right? So the rich folks had lighting and heating, whereas the masses didn't necessarily. So use of oil in human history continues. We'll skip up to the Middle Ages, right? So one of the most iconic images of oil use in the Middle Ages is this notion that you would defend your castle, right? So you've had all of your soldiers up on the ramparts, If you've been watching a lot of Game of Thrones lately, probably dial into this. And according to legend, they would take these jugs of hot oil and they would pour it down onto the invaders. So that happened, right? That was documented to happen in maybe 7 or 8 battles, maybe 7 or 10 battles. I don't know I'm not a historian, but I looked into this quite a bit. It turns out it wasn't a very reasonable thing to do because hot oil, well, first of all, the oil is expensive. And so you could pour it down and it worked great, cooked the skin off of all the invading soldiers. But they lost their footing. But after the war was over, you had a big slippery mess. It turns out it was actually much more common to, first of all, heat up giant vats of sand, because you can heat it up really hot, 300 or 400 degrees Celsius, dump it on the people, it works pretty good, then you don't have a mess in the morning. But also they would take smaller amounts of oil and use them for incendiary projectiles, right? Like flaming spears that they'd throw down on the people. So still pretty cool. So oil as defense, oil as a weapon. But again, that's not really what we use it for today, although maybe in very limited quantities. But mostly what we use oil for today is to refine it and use the energy out of it, right? So let's forget about marauding invaders and burning them with our oil. Let's get into the kind of more modern oil industry and recovery. So in the United States, the first commercial oil well, the first successful oil well was actually put in the 1850s, 1858, I think, in Canada. And it's actually still producing, although very anemic amounts, just kind of a historic well. But in the United States, the first commercial well is what's known as the Drake well. And actually, there's a lot of politics that are involved and a lot of kind of interesting stories that revolve around the development of the Drake well. You can see here is a picture of it in its heyday. It had basically an oil derrick, right? And so that was how they drilled the well down deeper. I think it was drilled to a depth of maybe 65 or 70 feet. It was fairly shallow. You can actually see here, this is a modern recreation. So it's actually now in Pennsylvania. It's a state park, the Drake Well State Park, I think is the name of it. And so this is the recreated well house. And again, in your reading this week, you've hopefully read a lot about Drake and kind of all of the notions of they had kind of chemically realized this material was going to be valuable. And so the Drake well really kind of kicked off an oil rush, right? So people were starting to realize that this material had incredible use and investors started showing up. So as a response to the Drake well, we really see the emergence and the formation of oil companies, right? The modern oil world. You can see here, advertisements. All of a sudden, this stuff was widely available. So in the early days, drilling an oil well was really about taking a rotating piece of metal and driving it into the ground. So you can see here, these are some early oil exploration folks, trying to drive their rotating piece of metal into the ground. We've come a long way. There's actually been a few different iterations in drilling technology. But in the modern world, we basically have, here you can see there's a bit. So there's a drill bit that's got these, it actually kind of looks like a stump grinder if you think about it. A drill bit that's wider, and it's driven or it's spun by a hollow tube called a drill stem. And so you can see, let me go ahead and draw a cross section of that. So here, so this is kind of a cartoon version of how this works. So this would be our well. Surrounding that, this is our bedrock material. And as this drill is rotated, the little blades chip off material from the surrounding rock. Now, you might start to think, well, now there's a space problem, right? How do you get that material up? And that's kind of the genius, one of the genius parts of how the system works, is that this stem that's rotating this bit is hollow, right? It's a hollow pipe. It's thick walled, it's a strong pipe, but actually mud and fluid mixture is injected down into the drill stem and creates high pressure here, and that actually, in the surrounding area behind the drill, that mud then shoots back up to the surface and comes out the top of the well head. So if we were to think about this, I'll draw a cross section that's a little bit larger. So this is pretty simplified, but there's a turntable that's driving our drill stem, and then remember that mud, which is keeping the area down at the bottom of the well at really high pressure, that mud then runs back to the surface, and in most cases is actually collected or kind of allowed to spill out. And in that mud is rock chips and basically the equivalent of sawdust, right? If you were to take a drill and stick it in a piece of metal. So we use fluid to draw that material out and to keep this going down.